I'll discuss only concept on lens, right? So today class, I'll target theory first. Once I'll complete the theory, then I'll do means and advanced PYQs, right, my dear? So have a look up today class. Okay. So this is students. I can say in today class, as I said, Thamil already mentioned. I'll teach that is what, my dear, concept on lens, right? So Vita, I can say lens. You can ask what is lens. Lens are the transparent medium bounded by two spherical surfaces. What is lens? Lens are transparent medium bounded by two spherical surfaces. That is what lens. Okay. Now, students, I can say, as I said, definition. Students, as I said, this is definition of lenses. Next, student, I'm going to discuss that is what I can say. This is types of lenses. What, my dear? I'm going to discuss next one. That is what types of lenses, right? So basically, student, in our syllabus, which is mentioned, types of lenses are in two types. So this is what students. First one, you can say this is thin lens. Next, my dear, you can say that is what thick lens. Right. Okay. So students, you can ask, how can we decide which lens, thick or thin lens? So the way how lenses are made by using two spherical surfaces. What students, as I said, the way the way how lenses, the way how lenses are made by spherical surfaces. So this is what students, you can say this is the shape of lens. So this is what, my dear, you can say this is the convex lens. The way how lenses are made by using two spherical surfaces, right? Now, students, so we can say this is what, my dear, this is convex lens. This is what a student? Convex lens. Okay, this is firstly. Next, students, I can say in second, that is, as I said, the way how lenses are made, the way how lenses are made by using two spherical surfaces, right? So here, students, I'm going to tell you, I can say this is what another kinds of lenses. So this is what, my dear, you can say this is nothing but it's a concave lens. This is what, my dear? This is, you can say, concave lens. So this is a convex lens, my student. This is, you can say, this is concave lens. This is what, my dear? Concave lens. So in our syllabus, there are mentioned two types of lenses, thin and thick, right? So basically, I'll discuss more about what students thin lens, not much thick lenses, because in our syllabus, which is mentioned, my dear, only thin lenses for detailed study, right? So now, students, I'm going to categorize types of lenses, or you can say nomenclature of lenses, right? So, student, what is the next topic here? This is students. Either you can say nomenclature, you can say, my dear, nomenclature, or you can also say types of lenses. What, my dear? Types of lenses. Okay, very nice. So basically, beta, I can say generally, no, in the paper or like can say in the examination hall, they will not say convex lens. Rarely they will mention convex lens and concave lens. So they will generally mention that is what, my dear? by y convex lens. This is what, my dear? By convex lens, right? So beta, why convex lens? Yes, convex lens is nothing here. It's what you can say by convex lens. What you can say, this is the biconvex lens. Second, students, you can just keep in your mind. These all are nomenclature will help you a lot to just crack their numerical. What is students? Next one, plano. This is plano convex lens. This is what, my dear? Plano convex lens. Okay. Third, students, I can say this is concavo convex lens. Concavo, concavo convex lens. Right. So here, students, what you can say like that here. Hmm. Yes, beta. This is what you can say concavo convex. What you can say, this is what concavo convex. Sometimes, students, you can also represent just that is, I can say thin lenses. These all things beta which I said for thin lenses here, right? Sometime beta you can also represent. This is what a representation of beta. You can say this is the basically thin lenses. So these all are, I can say, representation, and these all are the name of what you can say convex lens. What you can say, my dear, convex lens. Okay, so now students, I'm going to discuss next. That is what I can say type of concave lens. What is next, student? This is type of type of convex lens. Okay, fine. So this is beta as usual. You can say this is what, my dear, by concave. This is what? By concave lens. Orbiter, sometime you can also call that is equiconvex, concave. Both are remains the same. So this is, students, representation of by concave lens. Okay. Next, students, that is plano concave. What, my dear? This is you can write plano concave. Okay, next, students, this is third one. You can say convexo, convexo, concave, convexo, concave lens, right? So this is the, students, I can say way which you can remember. I can say with a kinds of things there. So this is what convexo concave. So I can say yes, but more importantly, you can also remember that is what representation of beta concave lens. This is what, my dear, representation of concave lens. Okay, fine. Now, students, I'm going to derive that is a formula for, you can say, derivation of lens maker formula. What is, student? I'm going to derive derivation of this is lens maker formula. Okay, fine. Come, students. So now, as I say, maximum time I'll use thin lenses because that is, I can say, recommendation for detailed study. So now, students, as usual, basic point, I hope all of you remember, this is the principal axis. This is what, my dear, principal axis. Now, students, this is the concave lens. This is the concave lens. Here, I didn't discuss about sign convention, you can say formation of images and all, because I'm considering you already knew, because already I taught. right? So how image formations can take place. But one thing I can tell you, student, for here, always we can take here sign convention with respect to what, my dear? With respect to what? You can say that is a whole of the mirror, a whole of the lenses there, right? So just keep in your mind. Everything beta, I'll just take in consideration sign convention. I can say for about this axis, right, student? Okay. So this is object is here. Here is student, I'm considering point object, right? So object beta rays finally from here to here falls on the lenses. I hope all of you remember refraction, rarer to denser. You can take better. This is a refractive index as air is equals to 1. This side also spreads. You can say mu is equals to 1. For lenses, beta, I'm not telling any numerical letter. Let us say I'm considering this is what mu. This is what my students mu. Okay, so I hope all of you remember if ray is going rarer to denser, so what we can say towards the normal. Beta, what you can say towards the normal here. So beta first you can just make normal over here. So ray beta, what you can say this is towards the normal, right? And now it's again ray form here. They can take place with the party formation of rays. So this is what I'll make students normal over here. So ray is what denser to rarer away from the normal. What you can say, beta, this is what away from the normal layer. So just now, students, I'm going to just make further diagram. Right. Okay. So let us see object distance, students. This is u. This is the first time refraction. So this is, you can say, let us say this is what? Sprint V1, right? Okay, fine. Then students, no object, I can say ray will not stop over here. So ray again will perform one more refraction, and that is your final image. And that is what, student, your final image. So this is what you can say, this is V. This distance, what you can say, student, this is what V. Very nice. Now, these all things here, which I said, I can how to formation of image takes place. Now, students, I'm going to discuss here. First, I'll apply reflection one time over here. Let us say this is surface one. In fact, it's required here. So, students, I'm calling this is R1. This is what, my dear? R2, right? So student, first I'll apply a refraction at here. Then, my dear, I'll apply refraction at the surface. So refraction formula here, I hope all of you remember. I'm expecting because that is a part of last week, right? So for refraction, here is student, I'm telling you formula of refraction at a, I can say, a spherical surface. So for surface, student, for surface 1, I'm going to apply a refraction at a spherical surface. So what's the formula here? I hope all of you remember. Otherwise, I'm telling you N2 by V minus N1 by U is equals to N2 minus N1 upon R. That's all. So here, students, you know how N2 I said here, rays were finally going to stop. That is N2. So ray beta is stopping over here. So don't be confused. What you can say, N2 is equals to mu. N2 is equals to mu beta. So you can say mu by V minus N1 beta in area only. So you can say 1 upon, this is what, dear? U. Here I'm not considering U and V with sign convention. Keep in your mind. Okay, then beta, what you can say, mu two remains as usual, mu minus 1 upon. Okay, if you remember here, as I taught in bridge course, if ray is falling on this part, just keep in your mind, it's highly required here to know how this is, how can we say plus R1 and minus R1. If ray falling on this part, Students, it's highly required here. Just keep in your mind. If ray falling on curve part, if ray falling on curve part, then what you can say, bacha? This is nothing but it's a what? We can say plus radius. Radius is plus. If ray is falling like here, then what you can say? This is what? Negative. So here, beta, I can say for R1 here, ray falling over here only. So what you can write? This is what? Plus R1, bacha. So here you can say this is and mu by v minus 1 by u, mu minus 1 upon beta r1. Let us say equations number 1. This is what, my dear, equations number 1. Okay, now students, I'm going to apply refraction at surface 2. So for surface 2, for surface 2, this is what, my dear? Refraction here. So now a ray is moving from here to here. So keep in your mind, this is 1, this is 2. So what you can say? 1 till bacha party. So here, yeah, I can see formation of image here only. So you can write this is V1, right? 1 by V bacha, it's the final image. Minus students, you can say mu by V1, which is equals to N2. N2 is 1. So keep in mind, 1 minus mu upon beta, what you can say R2. Say equations number second. Say equations number second. Now, students, basically our baby is to find relation. So simply beta, just you can add here these two. Simply, student, you can add equations number 1 and 2. Simply, student, add equations number 1 and 2. Then what you can say, sir, these terms cancel each other. You can say easily, sir, these terms and this term cancel each other. So finally, you can write, my dear, that is what, students? What you can write finally? This is 1 by V minus 1 by U. For addition here, you can say, bacha ji, yes, finish here. So you can take beta mu minus 1 common here. So we can write mu minus 1 into beta g 1 upon R1 minus 1 upon R2. 1 upon R1 minus what you can say? This is what? 1 upon R2. Right. So this is what students you can say Lane's maker formula. Keep in mind, it's a highly important, my dear. 1 by V minus 1 by U is equals to mu minus 1 into 1 upon R1 minus 1 upon R2. So this is what is known as Lane's maker formula. Keep in mind, beta. Keep in mind, students, this is lens maker formula. I can say it's a hero formula for lenses. Okay, come to the point idea. So now, students, I can say we can simply uh, this is the same formula. You can change lens maker formula. You can convert in lens formula. How this is, my dear? Have a look. So what we derived here finally now, this is lens maker formula. 1 by V minus 1 by U is equals to mu minus 1 upon R1 minus 1 upon R2. Right, students? Okay, so same formula. Now I'm going to convert, my dear. I can say for Lane's formula. Okay, so what I can see is from here, just I'm considering a few assumptions. I hope all of you remember. Students, let us say, I'm just considering, let us say, students, if U is equals to minus infinity. So what is formation of image here? Formation of immediate focus. Formation of immediate focus. So same formula beta. This you can see entire term something upon infinity. Something upon infinity. What you can say zero only. So V beta F only. So same formula beta. This is the Lens maker formula, my dear. Going to convert. That is 1 upon F is equals to mu minus 1 into 1 by R1 minus 1 by R2. So this is your Lane's formula. What, my dear? This is You can say lens formula. This is the lens maker formula, students. Okay, all formula, these all formula with applicable read are paraxial. Medium should be same. Yes, what I derived, the students, you can see here also, re is paraxial, and already I can say lens left and lens right side. Both I can say lenses I kept means beta same medium only. Yeah. Okay, so have a look beta. Few numerical, basics numerical based on this. So what's the numerical beta? Let us say I'm considering here, I'll take any random data. If you want to tell, then you can type in chat box. So this is their lenses, right, students? Okay. Here I'm going to tell you, otherwise it's not required. Rays coming from, I can say this side. Rays coming from this side, right, my dear? Okay, fine. So this is what, my dear? It can take 1.5. It's a refractive index of lenses, right, students? Outside bit I can take. I'm considering here n is equals to 2. Here also n is equals to 2. Okay. Radius beta you can take this radius you can take students 20 centimeter. This radius you can take a random data 10 centimeter. Right, my dear? What's the question? Find focal length. Find focal length. Okay. Come to the point, my dear. So how can you do it? Yes. Have a look. Just now, I derived the result how to find focus. So you can use here straightforward this result only. So 1 upon f is equals to mu minus 1. So what's the mu? What's the mu beta z? Mu of lenses upon what? You can say bacha mu formula beta. You can also just this formula you can just change little mu of lenses upon mu of surrounding minus 1 into beta 1 upon R1 minus 1 upon R2. So further students, just substitute the value of this. So mu of lens is how much? It's 1.5. Mu of I can say surrounding, that is 2 minus 1. 1 upon R1 with this is all as I said here, it's positive only. 1 by beta, it's 20. Re coming like here with us. So what is minus minus plus here? So this is plus 1 by 10. So further beta, this we calculate 1 upon beta. This is 3 by 2. So you can say 3 by 4. So 3 by 4 minus, just write one step more. 3 by 4 minus 1 into this is what, my dear? It's basically 200. So this is 10 plus, you can say 20. 3 by 4 means 4 goes up. Beta. Just take LCM of it. 4 minus 1. 1 by 4 basically. Now beta. So you can say this is, I wanted to write here answer only, students. 3 by 4 minus 1. So you can say finally, sir, this is minus 1 by 4. Into beta, this is, you can say 30 upon beta is the 200 here. So this is cancel beta. So you can write minus 3 by 80 in centimeter. It's 1 upon f. So keep in your mind. Focal length, what you can see? This is 80 by 3. What is the meaning of minus H? What is the meaning of minus distance? Till now I didn't tell about converging and diverging. So if we are getting focal length negative, so what I can say, length, what is the nature of lenses? That is what you can say. You can say, bacha, for diverging. What you can say, my dear? This is what you can say basically diverging. Now, so just do everyone next questions. There is, what's the main point for this question? Either you are considering ray from this side or this side. There is no change in value of focus. Focal length you will get as usual. The same what I found over here. Now, students, have a look at this is question for your self practice. I'll give you 30 seconds. You can try these questions. This is my dear, it's a principal axis. Okay, fine. So just take it outside. It's air only, outside air only. And this is what, my dear? 1.5 mu of lenses you can take. Radius beta, you can take this side 30 centimeter. I can take this side 20 centimeter. Questions? Find focal length. Yes, I'm giving you 30 seconds here. You can try these questions. I'll solve after 30 seconds. Yes, beta. Answering this question, you have remaining 10 seconds here. After 10 seconds, I'll solve this numerical. Okay, fine. Now, students, time which I gave you completed here. So now I'm going to solve these questions. Have a look. So here beta we used to find basically focal length. So students, first to crack these questions, you have to just remember what's the formula of focus. So this is 1 upon f is equals to mu of lenses, mu of surrounding minus 1 upon R1 minus 1 upon R2. So, student, further here, just substitute the value. V of lens is beta, mention here 1.5. So, you can write 3 by 2. For air, you can take 1 by d. This is 1 upon R1. As I said here, if ray falling on this surface, this is the positive vector. So, this is what? You can say positive only. So, what, my dear? You can say 1 by 30. Ray beta again coming same side only here. So what you can say, this is what remains beta, positive only. So you can write 1 upon 20. So 1 upon f beta, you can write 3 by 2 minus 1 here. So this is basically point 0.5. Point 0.5, my dear, and this is, you can take LCM 600. So this is 20 minus 30. So we can write 1 upon f is equals to 1 by 2 minus 10 upon 600. So cancel beta. So what you can see here? F is equals to minus 120 centimeter. So this is answer beta for these questions. Right. So have a look beta next concept here. I hope all of you getting the class. Now beta next year. Uh, converging lens. Converging lens beta. This is what it's converging lens. So what is the converging lens, my dear? If all of you remember here, as I thought, I can say, Bachaji, for mirror here, if ray is coming parallel to principal axis, if ray is coming parallel to principal axis, what you can see, converge at focus. If ray is coming parallel to principal axis, so what you can see, ray converge at focus, right? This is the point, beta, which you can keep in your mind. So, how can we say instead of lenses converging or diverging? Students, if you are getting focal length is positive. So, what you can say? We can say given a combination of lenses or given lenses belongs to what? Converging lens. Okay, fine. Next, my dear, this is a diverging lens. This is what, my dear? Diverging lens. So, students, yes. So, now students, see, principle you can apply if ray is coming what? Parallel to principal axis. What you can say, ray finally got diverges and meet at focus. Ray finally bit about diverges and meet at focus. A ray finally diverges and beta what you can see meet at focus. So here beta for diverging lens, you can just keep in mind if you are getting focal length is negative, so you can say given combination of lenses or given lenses belongs to what? Diverging lens. Belongs to what, my dear? That is what you can say diverging lens. Here I'm not going to teach you like ray tracing and all, right? I'm going to just omit that part. Now, beta, just I'll discuss here. I can say little point only. Primary and secondary focus. Primary and secondary focus. In fact, that is also not a point to discuss over here. Okay. Now, beta, just go through here. Next concept only. These all point to remember everything. No, beta, I can say main focus. You can say here primary focus. Main focus. What you can say basically primary focus here. Okay. So, what's the next concept, students? This is transverse magnification. This is transverse magnification for lens. Transverse magnification for lens beta. Okay, come to the point here. You can also say it lateral magnification. Both are remains common only. So, student, this is the principal axis. This is the principal axis. This is, I hope all of you remember, it's a converging lens. Right. So let us see screen here. I'm considering this is what S is the height of object. So if ray coming parallel to principal axis, then what you can say ray finally till beta passes through focus only. Ray finally passes through focus only. Okay. Another more. I wanted one more raise here. So if I hope all of you remember, if ray is what passes through pole, then what you can see, ray can cross this pole without deviation. I hope all of you remember at these points also. So now, student, this is the height of object. Now I'm calling my dear. This is the height of image. This is the height of image. Students, this one I'm calling U, and from here to here, student, this is what V. Okay, student, this angle I'm calling theta. So you could easily say, sir, this is also theta. This is also theta, right? So now, students, I'm going to apply basic formula of I can say tan theta. Let us see beta for this triangle here. Beta, here initially students here I'm going to discuss or I'm considering here this triangle only. So for this triangle beta, for I wanted to write tan theta. So what we can see, this is perpendicular upon base here. So this is H O by U. Say equation number one. Next students, I'm going to just considering this triangle, right? So again, beta, I wanted to write here tan theta. So this is what hi by v. Say equations number second. Let us equate these two here. So what you can write because both angle remains same picture. So HO by U is equals to HI by V, right, my dear? So finally, here, you can write over here HI by HO. This is V by U. It's nothing else. What you can say, it's a magnification. I hope you remember, students, magnification formula, I can say for mirror. What we learned? We learned basically what beta I can say magnification is negative minus b by u. But here beta, what you can say? It's a plus b by u. What you can say, my dear? It's a plus b by u. Okay, few basic point here which I wanted to tell you so that we can beta I can say will solve easily numerically because here I'm not going to discuss in much detail like mirror for erect image or I'll write here students for students erect beta V U H I and H O have a same sign. What is means you can say have a this is have a same sign. Okay, data for inverted student for inverted. This is just opposite of lenses over here, which are V U H I and H O have different sign. This is what, my dear, different sign here. So just keep in your mind, bacha, because now here I'll just do numerical only beta. Okay, now students, let us say this is the principal axis. Students, here I'm considering biconvex lens, right? But student, one thing, uh, you can take refractive index for environment, that is 2s. You can take 2, n is equals to 2, my dear. Okay, fine. Students, here I'm considering, yes, rays coming from infinity. Ray beta coming from infinity. So this is initially I'm considering height of object, which is equals to 4 centimeter. And it's a virtual object, my dear. It's a virtual object. Students, it's a virtual object. Okay, fine. Find uh you take beta. Students, you can take this is 60 centimeter. Both surfaces, students, you can take here, radius remains common. So R is equals to, you can take 20 centimeter. Find following here. So find first, find following. Yes, beta. You have to first find focus. Then a student, you have to find height of image. You have to find height of image. Or I can also share magnification also. So now student have a look at solution of these questions. Yes, beta. So for solution, I hope yeah, all of you remember one formula which I gave, I can say in mirror bacha. So that formula there is in reverse order here. So simply beta, just find focus. You can simply apply, my dear, U into F upon beta z u plus f. So it's a virtual object. So u beta what you can take? It's a virtual object here. So u beta what you can take here? It's positive only. And you can say because here, as I gave you, this is what beta z radius. So you can't use this formula directly over here to get a focus. So what I can recommend you, first we have to find v. So how can we get v, bacha? Just move on the next paper here. So for getting v beta, we can apply formula here. Lens maker formula. 1 by v minus 1 by u is equals to mu of lenses upon mu of surrounding minus 1 into beta 1 upon R1 minus 1 upon R2. Right, students? Okay, so as I said here, U, it's a virtual object. So I'll take U is equals to plus 60, my dear. So this is what, my dear? 1 by V minus 1 by 60. Then beta G, mu of lenses here. Okay, you can take beta 1.5. So this is what, students? 1.5, you can write 3 by 2. And environment also 2 here. Environmental lens beta refractive index here, 2 only. So we can say this is 2 minus 1. 1 upon R1 which is A. So what about 1 upon R1 here? Because both are positive only, as I said. So this is 1 upon 20 and minus plus. I hope all of you understand here how I wrote plus. So 1 by V minus 1 by 60 is equals to minus 1 by 4 into 2 by 20. So you can say this is cancel. So 1 by V minus 1 by 60 minus 1 by 2 into 1 by 20. So we can say minus 1 by 40. So 1 by V can write finally, this is minus 1 by 40 plus 1 by 60. So 1 by V beta, you can just take LCM here. 40 and 60 LCM, bacha. This is 20 times 20 and this is 3, 20, 40, 120 beta. So this is 120 minus 3 plus 2. So you will get 1 by V is equals to minus 1 by 20. So what's the image distance here? We'll get V is equals to minus 120 centimeter image. So this is what image not real here in the lenses. What we can say it's a virtual image. Yes, beta. Keep in mind here. This is what students you can say it's a virtual image. This is what you can say it's a virtual image. Okay, fine. So finally, you got with a value of V. So we can simply find here focal length also everything what you want to find. So let's say you want to find focus here. So just we'll go through this bacha. So you can say 60 into F upon beta is 60 plus Fx. So V how much? Minus 120 is equals to 60 into F upon beta is 60 plus Fx. You can see 2 time cancel. So minus 2 into 60 plus F is equals to F here. So it can be just further just calculate my dear. Minus 120 and this is what? Minus 2F. It's equals to F only here. So minus 123 but cancel. So F you will get minus 40 centimeter. F you will get minus 40 centimeter. Further, students, this you can apply a formula of magnification. You will get HI. So, beta for HI, what you can write, my dear? I'm going to use your formula HI by HO. This is V by U beta. So, HO beta already mentions, which is 4 centimeter. V beta Z minus 120, U beta Z plus 60. So, you can say beta cancel minus 2 times. HI, you will get this is minus 8 centimeter. What does it mean? You can say formation of image takes place beta what? Beta, this is positive here. So image formation beta, I can say down the principal axis. Image formation, what you can say, my dear? Down the principal axis here. So just keep in mind these all things which are highly required beta. Okay. So beta I can see first I thought because if you remember there are two types of magnification in mirror also. In lenses also we have two types of magnification. First, I thought that is the transverse magnification. Next, students, I'm going to teach you that is what I can say longitudinal magnification. What's the students? Next one. This is longitudinal magnification. Okay, for longitudinal magnification, bacha, right? This little point here. Just go through this. Let us say, students, I'm considering this is what principal axis, right? Now, students, this is convex lens. Here, students, I'm placing objects in between center of curvature and focus, right? So, this is again bit of focus. This is 2F in center of curvature. So, just bit, I hope all of you remember if your object is lying, students. If your object is lying here, I can say center of curvature and beta focus here. So what is the formation of image takes place? Just keep in mind, this is a small object. This is what, my dear? Small object here. So finally beta, you can see this goes over here. And what beta? We can see perform a refraction over here, first surface towards the normal. Then beta what? Away from the surface is here. So finally you can get my idea that is what image over here. Students, finally you can get over here that is image. Okay, just keep in mind longitudinal magnification defined only for small object. Yes, beta ji. Come to the point. Now, students, here I can say a bit. This is the distance is everything I'm considering, my dear, from the whole of the lenses. So this is x. Let's say, my dear, this is dx. Right. Students, here as usual, I'm calling this is the distance, which is what, my dear, by, and this is what, students, dy. As I said here, this is defined for a small object. Right, my dear? Okay, fine. Come to the point. So, beta for sign convention here, I can say 1 point. This point you can take as a origin. This side you can take negative. This side you can take positive. That's all. So, which are here, I can say u is equals to minus x. It's object length. I hope you agree. Now, students, we image distance here, which is equals to we can write plus y. Focal length here, I can take always. That is positively for convex lens. So here, students, I'm going to apply the I can say beta that is a lens formula here. So what's the lens formula? 1 by v minus 1 by u is equals to 1 by f beta. So v is what? You can write 1 by beta minus minus plus. I hope you agree, my dear. This is 1 upon x plus, sorry, it's beta 1 by f only here. So just differentiate beta both side here. So beta here I can write, uh, I hope all of you remember the differentiation. So this is what, my dear? D by upon by a square minus this is dx upon x square, which is equals to 0, which is equals to 0. So finally, bit I can write d by dx is equals to minus y square upon x square minus y square upon beta. What you can say? X square. Right. So this is what beta formula here which you can remember. But one more point beta which I wanted to discuss and I wanted to connect here. Easiest way you can remember this formula. That is what, my dear, I can say magnification formula. Just now we remember everyone here. I derived the result. M is equals to what, my dear? V by U. So this is M. You can write d by dx is equals to what? This is plus m square because it's a mod. So it's nothing but I can write here. ML is what? It's a longitudinal magnification. Dy by dx. If you remember everyone, already I give result here. It is in the mirror for magnification. That is, there is a minus signs. If you remember, what I can say previously here, which I said in the mirror, that is a minus signs whatsoever. Okay, so here you can remember here. Previously, I said for longitudinal magnification in the case of mirror. Now I'm going to tell you longitudinal magnification for lenses. So this is what? Width of image. What, my dear? Width of image. Upon beta g, this is width of width of object. This is what? Width of object. So by this way, beta, we can remember this thing here, right? So we can also write m is equals to axial. M for axial, because we are discussing about axis. So we can also convert same formula dv upon du, which is equals to v square upon u square, which is equals to m square. So you can just keep in your mind. Same formula beta, you can also convert for aerial magnification. Same formula, students, you can also convert for this is aerial magnification. So this is area of image upon area of object, which is equals to v square upon u square, which is nothing but it's m square. Right, my dear? So this is which I said about, I can say, longitudinal magnification. Now, students, further here, I'll discuss numerical, but before that, here, I wanted to remind you, right? Because already I said, I taught, Bachaji, XM, XL, VMBL. Betaji, this is students, XM. Next, Betaji, this is XL. And then this is VM and VL. Okay, you can ask, what is this? Okay, students, XM, I can say it's a convex mirror. Students, XM is what? Convex mirror. So how can you draw graph for V versus U? It's very simple, student. It's literally very simple. So just keep in mind, this is V and U. So we can just make graph in first quadrant. It's as usual. You can remember in first quadrant and just take simply beta. That is what mirror image. You can take, my dear. It's a what? Literally, yeah, it's mirror image. Yes, bacha. So you can just make graph like this. It's a mirror image. It's literally easy, bacha. Just make first in first quadrant, then beta take mirror image. Next beta, this is action. What second one? This is you can take XL. So this is V and this is U. Now, student, for this condition here, you can draw graph in second quadrant. right? XM, XL, VM, VL. And just beta, just take mirror image here. So beta, this mirror image you can draw like this. It's literally it's highly easy, and just keep in mind. XM, XL beta, convex mirror, convex lens. Then बच्चा जी VM, concave mirror. So here you have to draw graph in third quadrant, right, my dear? Okay, and check students. Yes. So now students finally you can write over here. Yes, XM, XL, VM, and VLR. This is what concave lens. So here, student, you have to draw the graph in fourth quadrant here and take mirror image. So this is what, my dear? It's in fourth quadrant, right? Yes, bacha. So now student, just take a graph like this. All graph passes through origin only. This is the easiest way to remember V versus S statement everywhere. I drawn graph V versus U. I drawn graph beta what I can see V versus U. Right, Vijay. Next concept here. Effect of motion of object and lenses on image. Right. So beta this will go through next. How can I do? Yes, beta. Next concept here. Effect of effect of motion of object and lens of image. Okay, come to the point. Yes, beta. So how can we do bacha party this one? Okay, same formula here, which I can say you can use this formula same, but you can differentiate with respect to time. Right, beta. Same thing I'm considering here. Same data from here only, right? Everything bacha party. Same thing I'll use, but I'll differentiate here with respect to time only. That is simple thing, bacha. So we can say 1 by V minus 1 by U is equals to 1 by F. So students here you can write 1 by minus 1 by X is equals to 1 by F. Differentiate both sides. Differentiate both sides with respect to time. Differentiate both sides with respect to time, my dear. Okay, so this is what you can see beta 0 here, and this is what minus 1 by a square by dt minus 1 by x square dx by dt. Right, my dear? Okay, so further here, just equate beta both sides. So you can write 1 by a square by dt is equals to 1 by x square dx by dt. Minus here. So you can say by dt by a square upon x square dx by dt, right? So everything beta we are just as I confine with respect to motion of both of the things, right, my dear? So here I can write velocity of this is what, my dear? Velocity of image, velocity of image is equals to what? Again here, forget to put minus over here. Minus times beta, this is m by x here. You can write in terms of magnification, m square into beta. This is velocity of object. This is what you can say velocity of object, right? So beta, just keep in your mind here. Here I can apply same thing, bacha party, which you previously applied. Velocity of image with respect to lens is equals to minus times here, right? Bacha, you can say this is magnification positive here, na bacha? So you can be a positive, you can take positive one here. Into beta velocity of object with respect to lens. So this is beta, I can say golden formula beta, which you can keep in your mind, right? For I can say this is the if your this formula I can apply if lens is also in motion. This formula I can apply if I can say lens is at rest. So just keep in your mind, bacha. And M is what, bacha party you can say V by U or by X. Right, students? Next year, I can say this is which what I have taken beta. I can say for this condition, if your object motion along the, you can take here as a case number one, along the principal axis, along the, if your object motion, bacha, case one, along the principal axis. But if your object motion along the perpendicular to principal axis, right? Cases two, bacha. This is what, my dear. If your object motion, this is perpendicular to principal axis. Perpendicular to what, my dear? Principal axis here. Okay. So here's I'll use formula here. Hi by Ho. It's nothing but it's a magnification. I hope all of you remember. Differentiate both sides with respect to time, bacha. So you can write Hi is equals to m times of Ho. Differentiate both sides with respect to time. So this is height of image upon dt. M times of this is dho, height of object upon dt. So this is nothing but what you can see, velocity of image. Velocity of image is equals to m times the velocity of object. Both are in perpendicular directions. Keep in mind. Both are what you can see, perpendicular directions. Right. One more beta. As I said here in thumbnail, today I'll discuss more, means entire theory of lenses. If possible, tomorrow, if possible, then I'll take your next illustration, numerical based on this. Next, my dear, this is Newton's formula. This is Newton's formula. So, yes, beta, this is the principal axis. This is lenses, my dear. Okay, there is an object. It's a height object. Okay, so students, first ray is what? Parallel to principal axis. So what you can say, this ray finally what beta Z passes through focus only. I hope all of you remember. This is I'm calling beta F1, and this is what, my dear, F2. As I said, now primary and secondary focus. Okay. Next beta, I'll just next another ray which just passes through pole of the lenses. I hope all of you remember here. This ray can cross the pole without deviation. So this is what, my dear? Height of image. So I can see this is the height of object, this is the height of image. This is object and this is image. Right. It's the center of the lenses beta. Okay. So here students, because I'm considering over here, this is what my dear F1. You can also agree. I hope exovitasm. And this is I'm calling X1, right? Student, this distance from here, I can easily say you also agree. This is what F2. And this is the students I'm calling here. It's X2. Got it? Okay. So according to sign convention, what can I say? U is equals to minus times X1 plus F1. V beta G, this is positive here, as I said. So this is focal length. F1, F2 beta, here I'm considering same only here. Yes, beta G. F1 is equals to F2 beta, I'm considering same here. Okay, so this is what beta you can say F plus X2. Now, student, I'll apply here. Lens maker formula. Sorry, lens formula, not lens maker formula. Now, students, I'm going to apply lens formula here. So this is 1 by V minus 1 by U is equal to 1 by F. So 1 by V, you can say F plus X2 minus 1 by F plus X1 is equals to 1 by F. Simply as you can solve. You will get F is equals to what, my dear? X1 into X2. You can say F is equals to root of X1 into X2, my dear. Right. So this is the theory points which you can keep in your mind. Okay. Further beta, I can say there is a point here which I need to discuss. That is a major point. Silvering of lenses. What, my dear? Silvering of lenses. Before that, I wanted to discuss a student that is combination of lenses. This is combination of lenses. Right. Okay. So, I can see there is a very vital rule of combination of lenses. Combination of lenses. Okay. So, how student? If you, I can say, if already visited, like beta, I can say hospital for eye testing. So, you can see which are for that condition, for eye testing students during eye testing here, they are putting lenses one by one and they're asking, is this visible for you? Is this visible for you? Right, right. So, beta, for that conditions, what they are doing. Beta, I'm just here going to perform some experiment here. Let us suppose initially I'm considering lenses, one lenses over here only. Now, students, I'm considering over here, this is another lenses, right? Okay, fine. So, beta, I can if one. Let us suppose in hospital, if they already, I can say, put it one. They gave you one lenses to put on your eyes, but I can say that lens is not much sufficient to for clear vision. For that case, they will give you another one more lenses. Then, beta, I can see finally, yes, it's fine. So this is nothing, beta. There is a conditions here. I can say I'll talk later like image formation and all. So beta, that is for that conditions. You can just these two lenses you can convert as a equivalent lenses. You can convert as a what students? I can say equivalent lenses. Okay. Oh, Sagar. Hello, beta. How are you? Um. Oh, me too. Miss you too, beta. Okay, Sagar. So beta, this is how are you, beta? This is power equivalent. This is what, my dear? Power equivalent. So same thing, beta, I'll convert here in the form of what? F equivalent. This is what? F equivalent. Okay. So beta, as I said, this is example you can take here. Another example you can take for what? I can say converging of lenses. So what about converging of lenses? I hope all of you remember. If ray coming parallel to principal axis passes through focus, ray is coming parallel to principal axis passes through focus. This is nothing but what you can say it's a converging lens. What you can say this is the converging lens. Okay. So what is the power can be defined? Right? Because no, yeah, this is just take one more illustration to understand in better way. Let us suppose for this lenses, this is the focal length. Student, another you can take example here for the lenses. Okay, this is the formation of focus here only. You could easily say, sir, in this illustration, this two, I can say here, focal length is what? Less. Here, focal length is less beta. So how can we define power? So now, students, I'm going to defining that is what power. So power nothing here. Power you can write 1 by F. Power, what you can see, this is 1 by F. Right, my dear? Okay, so this keep in mind focal length you can take this one focal length with sine student. You can take focal length with sine. Okay, fine. What is unit of power here? You can't say what. You can't say what, right? What you can say unit of power is the aperture. Unit of power. This is the aperture, right, my dear? Okay. So now, students, I'm going to discuss power of mirror. Power of mirror. Oh, Sagar, you tell first. How are you? Power of mirror. Power of mirror. Okay, fine, Bacha. So power of mirror here. You can take. This is the beta mirror. It's a concave mirror, right, my dear? Okay, this is beta concave mirror. Okay, so I hope all of you remember here, if ray is parallel to principal axis, so what you can say, my dear, ray is what passes through focus only, right, now, beta? So power of mirror inverse is defined. P is equals to minus 1 by F, right? Power equivalent for combination of lenses. Students, power equivalent for combination of lenses. Power equivalent, power equivalent for combination of lenses, right, my dear? Okay, so what you can say over here, because no beta, there is two lenses here. So you can say P1, P2, right? So student, for this condition, you can write power equivalent is equals to P1 plus P2. So you can write F equivalent. F equivalent is equals to what, beta? You can say 1 upon F1 plus 1 upon F2 plus 1 upon F3 and so on. Just keep in mind, students, F1, F2, F3 with sign convention only. F1, F2, F3, beta, what you can write? With sign convention only, right? So, beta, keep in your mind here. These all points. Now, students, I'm going to discuss here numerical based on this. Yes, come to the point, my dear everyone. So, this is the questions here based on this. Okay, it's literally a consistent, it's a good number clear. So, just pay attention to learn how this is. Okay, students, there are here, students, I'm considering three lenses. Yes, yes, beta. This is what combination of three lenses. So, बच्चा जी, here, yeah, I'll take data. How? Beta, this is 2020. And this is 20 centimeter. And these two one students, I'm considering over here 10 centimeter. Right? Okay. Or one more thing here. Let us suppose that I'll take later. That I'll take later. We'll take R1, R2 like that. Okay. Think beta. This is mu1 is a refractive index for these lenses. This is what, my dear? This is what? Mu2 is a refractive index for these lenses. Mu3 is what? A refractive index for these lenses. So here you need to find individually F1, F2, F3. So what's the questions? Find F equivalent. Right, students? Okay. So now here I'm going to find one by one. It's your choice. Here I'm considering ray coming from this side, left to right. So this is the condition here, which you can keep in your mind. So this is what, my dear? It's a mu1. Ray coming from here, I'm considering. So this is 1 upon f1 is equals to mu1 minus 1 into beta. This is R1, R2 here. So it's 1 by R1 minus 1 by R2 because this is the lenses here, right? So I can just take in consideration. Just I wrote the formula only, right? Not entire thing with students. Next students for F2, for F2 beta. What you can take for F2 here? It's a concave lens. Yes, beta G. So for this condition here, again I'll take R1, R2. So this is what, my dear? Mu2 minus 1. No need to confuse sir here mu1 and mu2. No, not at all. This is 1 upon R1 minus. Here, students, just I'm writing formula. I'm giving approach. I'll take data R1, R2, then that will help you a lot. Now, beta, this is the third one. 1 upon F3. This is mu3 minus 1. 1 upon R1 minus 1 upon R2. Right. This is the point, bacha, which you can keep in your mind. Now, here, I'm going to give you like numerical based on this. Okay. Approach, just keep your mind with it. As I said you, this is, I can say length is 3. Now I'm going to give you basics numerical based on this. Then you will understand in a better way. Okay. Students, this is the condition here. Yes. This is a kinds of combination here. Now, students, here I'm considering there is water. There is a water. Okay. or you can take this diagram more crystal clear. Yes, this is the diagram. Yeah. Okay, fine. So for this condition, students, this is 20 centimeter. You can take care. This is 2, you can take. This is it's a plano concave. I'll tell you later how this is. And there is water. So water you can take 4 by 3. What you need to find? Find F equivalent. That much. Okay. So just beta, I'll go through this here. Be at 21 class only beta. Okay, step on here. So it's your choice. I'm considering ray coming from this side. So beta, I'll make this diagram like this. Yes. So this is a plane surface here. So you can take radius is infinite. And this is what, my dear? It's a 20 centimeter. This is 4 by 3. I'll apply formula 1 upon F. This is mu of length minus 1 into 1 upon R1 minus 1 upon R2. So this is one beta mu of length 4 by 3 minus 1. So you can say this is 1 by 3. Again, yeah, this is positive. So 1 upon 20. I hope all of you remember here. Radius of the straight line path, which is equals to infinity. Something upon infinity, what you can see 0. So you can write 1 upon F1. It's nothing but it's 1 upon 60 centimeter. Similarly, beta, just you can find here for F2. So for F2 beta G, what you can say, it's a concave lens. So just be careful here. It's a concave lens, my dear. So these two are what, my students? This is 20 centimeter. Right. Students, here. Ray, again, I'm considering beta from this side only. So this is what? Negative. This is positive beta. Just keep in mind. As I say, if ray beta falling over here beta, so this is a negative. Ray falling over here, then this is what? Positive beta. So we can say 1 upon F2 is equals to mu of planes minus 1 upon R1 minus 1 upon R2. So this is what, student? 1 upon F2. Mu is what? 2. 2 minus 1 beta remains 1 only beta z. Okay, 1 upon R1, yes. So this is the negative. Minus 1 by 20. And this is remains positive beta. So minus 1 by 20. Minus 1 by 10 beta z. Yes. So you can write, my dear, that is 1 by F2. This is what, my dear? Minus 1 by 10 centimeter. Okay. Oh, when you join Shubhang? Hello, Shubhang, beta. I'm very happy to see you. I'll do tomorrow morning. Yes, Shubhang, beta. Tomorrow morning I'll do. Tomorrow morning I'll do, beta. Shubhang, beta. Hello. Tomorrow morning I'll do, beta. For you. 100%. What are syllabus you can write in chat box once, beta. Subhang beta, just write syllabus beta in chat box. Tomorrow beta, I'll make plan. I'll make plan beta, Subhang, tomorrow morning. Just write in chat box beta, Subhang. Beta, stabilize. So this is beta, right? F2, yeah. Again, we have to find beta F3 also. So beta G for F3, this is right. Okay. So re beta, again here, I'm considering from here only. So this is what, students? It's 20 centimeter. It's a 3 beta. So I'll apply the formula over here only. 1 upon F3 mu minus 1, 1 upon R1 minus 1 upon R2 beta. So 1 upon F3 mu beta how much? 3 minus 1. The 1 upon R1 here. So this is remains positive beta g. And this is there. I can say for flat surface here. So it will goes to 0. So 3 minus 1 here, 2 only. So you can say 1 upon F3 is equals to 1 by 10 centimeter. Yes, beta. So this is the result there which you can keep in your mind. It's a bit highly required. Yes, beta. There, uh, yes, Subhang beta, tomorrow morning, 100%. Timing beta, you can take 10 o'clock. Subhang beta, 10 o'clock. Now you can leave the meeting, beta. I'm also going to just stop the class. I have few concepts only. Okay, beta. Bye. Tomorrow morning, 10 o'clock. Don't forget. So beta, I can see here we have to find F equivalent beta g. For F equivalent, you can write 1 by F1 plus 1 by F2 plus 1 by F3. So we are for 1 by F equivalent, 1 by F1, how much? 1 by 60, 1 by F2 beta minus 1 by 10 plus 1 by 18 here. So this is cancel only beta. 1 by F equivalent 1 upon 60 centimeter. Okay, fine with sir. Then beta, this will go through next year. That is the last concept. What is the slivering of lenses here? That's right. Last concept is from there for lenses only. So what's my dear next last concept of lenses? This is silvering, silvering of lenses. Okay, what is concept behind this Vita? Silvering of lenses, right? And cutting of lenses, yeah, that is the last point, right? Okay. So students, for this condition here, you can take any of the spherical surfaces, right? And just be polished this part. So we can see this is the what surface act as a mirror, act as a what mirror only, right? So what's the concept, students? Let us say this is what, my dear? It's a lenses, right now. So this is the object, my dear. So object, and now I'm going to silver this part of the lenses. So after silvering of lenses, lenses will act as a what? Mirror only. Lenses will act as a what? Mirror only, my dear. Okay. So this is the object here. Objects rays first entered from here, perform first time refraction, right, beta? And this ray what? Bends towards the normal. And from here again we'll perform once refraction. If what? Coming back after reflection from mirror, right, bacha bati? So finally you can see, bacha, this is densest to rarer. So away from the normal. This is the condition, beta, which you can keep in mind. Silvered face of a lens is equivalent to mirror. That is, I can say, a golden point for this concept. Silvered face of lens is equivalent to mirror, right? So, students, here you can write power equivalent, which is equals to twice times power of lenses. Because in why twice times? Because refraction happened two times, I can say, for lenses. So twice times power of lenses plus power of mirror. So as I said here, this after silvering of lenses will act as a mirror. So what is focal length of mirror? That is negative. So we can say minus 1 by f equivalent versus equals to what, my dear? Twice of focal length minus its mirror here. So you can say 1 upon fm. Just look at take my minus common here. So we can write over here 1 upon f equivalent, which is equals to 1 upon fm minus twice upon focal length. So this is the point beta which you can keep in your mind. It's a highly required. It's a highly required, my dear. Okay, fine. So there is one more question here I wanted to do based on this. Tomorrow I'll do more questions based on this beta. So find find students focal length. Find focal length. So this is the combination students. Yes, this part I can say beta. This part is silvered, right? And this is 4 by 3. Or you can take beta as a solar 20 centimeter, right? Okay, fine. So we wish to find what students? We wish to find what is the F equivalent, right? Okay, come to the point. Yes, Bachaji. So again here, no, what is easiest way to do this kind of question here? You can take beta refractive index for this. This is 2. Just solve individually one by one beta. So I can say for the solution, I'll take first beta this one. Okay, it is coming from here beta. I'm considering like this. So this is what, my dear? It's a 20 centimeter. So first I'll write 1 upon f1. Mu minus 1 here. So 4 by 3 minus 1 beta. I can write directly here. That is 1 by 3. 1 upon R1 what's the party? 1 upon R1. So this is which is the 20. R1 will take care from here. It's then beta for this is negative here, but I'm considering this from this only. So you can say this is what 1 by 20. So you can write 1 upon f1. It's nothing but it's 1 upon 60. Next beta, I'm going to find here f2. So for f2 beta, I'll say this is nothing but it's a convex lens. It is coming from here only. So F2 which is this is it's 2 only, it's 2020. So this is 2 minus 1 beta remains 1 only beta. It's negative here. So minus 1 by 20 and it remains positive here. So minus 1 by 20. So we can say 1 upon F2 is equals to minus 1 upon 10 centimeter. Minus 1 upon 10 centimeter beta. So this is our F1 and F2. So we wish to find F equivalent. Then we can find a focal length. So students for F equivalent of lanes only. Keep in mind. 1 upon F1 plus 1 upon F2. So 1 upon F equivalent of length is equals to 1 upon 60 minus 1 upon 10 here. 10 60 beta LCM you can say 60 only here. So correct only no beta. I have to check here 10 one time. Correct only 60. So this is 1 minus 6. So you can say 1 upon F equivalent is equals to minus 1 by 12 centimeter. This is F equivalent, which I calculated for lens only. Keep in your mind. Okay, fine. Then, Bachaji, Students, I can say, because we used to find entire equivalent length here. So what you can say, beta, for F equivalent. Now here, I'm going to apply formula beta, which I derived over here. 1 upon F equivalent for entire combination. 1 upon Fm minus twice upon focal length. Fm is what? I hope all of you remember here. R is equals to F is equals to R by 2. F is equals to R by 2 here. So with I can see 20 by 2 which are. So F is what? This is 10 centimeter. F is what was the party? 10. No need to take conventions. Already I have taken convention during I can see derivation. So 1 upon F equivalent is equals to 1 upon 10 minus here. 2 upon minus 1 by 12. So minus minus plus 2 6 are 12. 1 by 60. Now beta 2 6 are 12 in here. So further you can just solve it as 1 by 10 minus minus plus 1 by 6. So further here solve with party we'll get answer of these questions. Right. So this is a literally not a tough thing, but in the paper hall it's very much confusing. Right. Now beta I'm going to give you next number clear. This is your homework beta ji. Because yeah, I'm going to just stop live session very soon. So this is your homework numerical. Yes, beta. This part of lenses is silvered. This is what, my dear? 1.5. You can take. Find F equivalent. Find F equivalent. Student, this is basically your homework here. You can just solve and just write your answer in chat box. Okay. In comment section, bacha. So this is Vitaji focal length, which you can find. I'll see tomorrow. Now your last point, that is what I can say, cutting of lenses. This is what, my dear, cutting of lenses. Okay, yeah, here I'm going to just give you short trick. Right, what's the short trick here? Yes, for cutting of lenses, bacha. Okay, so Vitaji, I can say this is HSVG. I hope all of you remember here. HSVD. What does it mean? It is S for horizontal. For horizontal cutting, your focal length remains same. Keep in your mind. Next, students, this is what? V for vertical. So we can say for vertical cutting, your focal length becomes double and power becomes half. Better for this condition here. For horizontal cutting, focal length remains same, power also same. That's all. So how can you remember here? You can say Hong Kong, Simla via Dubai. Yes, beta. You can write over here H for what? H means horizontal cutting, focal length remains same, so power also remains the same. For vertical cutting, you can say focal length becomes double, so power becomes half. Hong Kong, Simla via Dubai. So this is the things here which you can keep in your mind. This is all about your today class. That is, as I discussed, as I taught you, entire theory of I can say for lenses. One more last numerical, but it's also students your homework, right? So now this is the lenses. Okay. So now I'm going to silver this part of the lenses. Again, you have to find F equivalent. Find F equivalent. You can take this is 1.5 or you can take this as what? 10 centimeter. Okay, students, I'll see tomorrow as usual if possible. Right, students. So this is all about I can see today class. Student, as I discuss entire theory of lenses. Tomorrow, if I'll get a time, due to time now, I'm not able to take your classes. If I'll get free tomorrow, I'll try to plan just discuss numerical. I hope all of you remember HSVD. Horizontal cutting focal length remains the same, so power also same for vertical cutting. That is what power gets double. So you can write over here S what? Hong Kong, Simla via Dubai. Oh, Atharva. Hare Krishna. How are you? Very happy to see bacha. Okay, Atharva, beta, do one question here. It's just because of you, beta. I'm just going to do this question. Otherwise, yes, yes, yes. Very good, beta. I can say this question you can do beta Atharva once because of you, beta. Only. Otherwise, I was planning to just terminate the class. Just answer me this question, beta. Before cutting students, this is the what I can say condition of lenses. Now, students, I'm going to cut this cut lenses horizontal cutting. Students, comment on focal length. Comment on students focal length as well as established Atharva as well as power of lens. Yes. Answer students. Answer students. If mirror along horizontal. Okay. Mm, okay. What's your answer students? Atharva, what's your answer, my dear, for this question? After cutting lenses, comment on focal length as well as power of lenses. Okay. Yes, yes. Beta, this is, I can say, you have a lens. Again, I'm repeating question, don't worry. Beta, you can take, this is your lenses, right? Got it? Now, students, initially, this is the lenses here. You can take like that. This is the lens. If if you cut if you cut the lenses along the horizontal, so you have to comment on focal length as well as power of lenses. Focal length as well as power of the lenses. Yes, Pitaji. Just answer me. Okay. Quickly, fast, students. Focal length changes vertically. Correct. But I see it's a horizontal cutting. So what's your answer? It's a horizontal cutting of lenses. So what's your answer? Remains the same or different? Correct only. Okay, students. Good year. Happy to see. I'm going to be just stop this live session. Correct, Atharva. Good, bacha ji.